Hi Trigoner, so we are going to graph quadratics from three different forms. This is Notes Day 1 from section 3.4. So we're going to take a look at standard form, vertex form, and factored form. So the first form I'd like to look at is vertex form. So we have y equals a times the quantity x minus h squared plus k, where the vertex is h comma k. And you might want to consider the parent function, y equals a x squared, and think of transformations. You could think of the parent function moved right h and up k, and a vertical stretch or shrink by a factor of a. So why don't we go ahead and look at this first example. We have y equals 3 times the quantity x plus 2 squared minus 10. So we could go ahead and write the vertex down. It would be negative 2 comma negative 10, because again we moved left 2 and down 10. And then you might want to think about what this parabola looks like. So again, we have negative 2 and 10. Notice the a is 3, so again that's a vertical stretch by a factor of 3. We know that the axis of symmetry is the vertical line that goes through the x coordinate of the vertex for this parabola. And we're going to have a minimum because again our a is positive 3, so our parabola points up. You could find the y-intercept. We know that if you let x equal 0, you have a y-intercept of 12 minus 10, which is 2. So again, now we want to get some points. You could think of, let's hold on to the increasing and decreasing until we look at our graph. Again, think of our parent. We went up 1, or right 1, up 1, but again, now we have a vertical stretch by a factor of 3. So we go up 1, right 3, left 1, up 3, and again, the point 2 comma 4 in our parent. But now with a vertical stretch of a factor of 3, we would go right 2, and 3 times 4 is 12, so up 12, and again, that is consistent with our y-intercept at 2. I think it might help if you go ahead and put your axis of symmetry. Helps our eyes a little bit because again we went right 2 and up 12, but we could go left 2 and up 12. So here is our here's another point. So we can go ahead and sketch a graph. For increasing and decreasing intervals, you want to think about x values. So our function is, we read a function like you read a book from left to right, so our function is increasing from negative 2 to infinity and decreasing from negative infinity to negative 2. Let's go ahead and look at the next example. Go ahead and think about the vertex, and we'll decide whether we have a minimum or a maximum, the axis of symmetry, and the y-intercept. Go ahead and pause the video and give it a try. I notice that my a is a negative 2, so my parent would have been reflected over the x-axis, so I know I'm going to have a maximum point. I went right 6 and up 3, so my vertex is at 6 comma 3, and my axis of symmetry is at x equals 6. So if I go ahead and plot some points, I have 6 comma 3, and notice that again I have my axis of symmetry at x equals 6. So again, you could think of your parent function that we went right 1, up 1, but again, since our vertical stretch is 2, we're going to go right 1, down 2, left 1, down 2, and again, our parent function went right 2, up 4, but our vertical stretch is 2, so we're going to go right 2, down 8, and we go left 2, down 8. So we can go ahead and graph our quadratic. If you let x equal 0, you find the y-intercept at negative 0 comma negative 69. And again, I'm sure that's consistent with our graph, but that's not really extremely helpful unless we change our scale. Let's take a look at increasing and decreasing intervals. Again, these are x values. So again, from left to right, we're reading our function. So we know that the increasing interval is from negative infinity to 6, and we are decreasing from 6 to infinity. All right, let's take a look at the standard form of a quadratic. Y equals ax squared plus bx plus c. And we're going to transform those two equations above into standard form. So we can go ahead and we have a the quantity x plus 2 squared, we can expand the quantity x plus 2 squared. So we end up with 3 times the quantity x squared plus 4x plus 4. We can distribute the 3 and combine like terms. So now we have standard form. Why don't you go ahead and pause the video and transform g of x into standard form. Okay, you can expand the quantity x minus 6 squared, and then distribute your negative 2 and add 3. And so notice that you have negative 2x squared plus 24x minus 69. So notice we are going to move into the next form. We're going to go ahead and graph a quadratic from standard form. So let's think back to, again, the general equation and what the axes of symmetry would look like. Notice the axis of symmetry would be the opposite of b over 2a, and the axis of symmetry, again, is the x-coordinate of the vertex. So if I wanted to find the y-coordinate, I would have to go ahead, to find k, I would have to go ahead and substitute x into the equation. And that would be to find the y-coordinate of the vertex k. Notice the y-intercept, you would let x equal 0 to find the y-intercept. So let's go ahead and practice with y equals negative 2x squared plus 4x minus 5. I'm going to find the axes of symmetry. So notice my a is negative 2, the b is 4, and the c is negative 5. So I have x equals the opposite of 4 over 2 times negative 2, so x equals 1. So to find the vertex, I'm going to substitute 1 into the equation for x, and I will find the y-coordinate of the vertex. When you substitute 1 for x, you end up with y equals negative 3, so the vertex is 1 comma negative 3. And now for the y-intercept, we're going to let the x equal 0, and you get negative 5. So the y-intercept is 0 comma negative 5. Okay, great job. Why don't we go ahead and sketch a graph. So for number 1, we're going to find our axes of symmetry, which is the opposite of b over 2a. A in this example is 1, b is negative 6, and c is 4. So I end up with x equals 3, which would be the x-coordinate of my vertex. So go ahead and pause the video, substitute 3 in for x in your equation, and find the y-coordinate of the vertex. So you have 3 squared minus 6 times 3 plus 4, so 9 minus 18 plus 4 is negative 5. So now we could find the y-intercept. If you let x equal 0, you end up with 4. So let's go ahead and plot a few points to get started. So we know that the vertex is at 3 comma negative 5. And we also know that the y-intercept is at 0 comma 4. We know that the a is positive, so there's going to be a minimum. Our parabola is our quadratic function. We're going to have it, it's going to open up. So you might also want to consider your parent function. Parent function y equals x squared. We went right one, up one. Notice for this particular quadratic, our vertical stretch is 1. So we go right 1, up 1. We could go left 1, up 1. Now we would go right 2, up 4. Left 2, up 4. And now we would go right 3, up 9. And left 3, up 9. These points are consistent, notice, with our y-intercept at 0 comma 4. So again, 2 points. I did go, let's see, I went 2 comma negative 4. Those are 2 points. And 4 comma negative 4. Because I went right 1, up 1, left 1, up 1. Notice that the axis of symmetry might help to visualize where those points would be. And there's our graph. So what I would like you to do now is go ahead and pause the video and try number 2. Okay, so I did x is the opposite of b over 2a. So I know that my axis of symmetry is that x equals negative 2. my vertex would have an x-coordinate of -2. If you substitute -2 in for x into your equation, you get y equals 9. Here's my vertex at -2, 9. Notice you could go ahead. Let's see, the y-intercept was at 1. And again, you could also use a symmetric point, right? You could think of it this way. And again, if you think of this with transformations and think of your parent function, notice that my vertical stretch is 2. And I knew that my quadratic would open down and have a maximum because the a was negative. So again, if you compared your parent function, it was reflected over the x-axis. So again, for our parent function, we'd go right 1, up 1. But here our vertical stretch is 2, so we'd go right 1, down 2, left 1, down 2. We would go right 2, down 8, because again, 4 times 2 is 8. And that would be, again, consistent with our y-intercept, and left 2, down 8. So again, 2 points, we used -3, 7, and -1, 7, because we went right 1, down 2, and left 1, down 2. Okay, let's take a look at factored form now. So go ahead and think about what the equation would look like if it was in factored form. Go ahead and pause the video and think about that. For factored form, you would have y equals a times the quantity x minus p times the quantity x minus q, where p and q are the x-intercepts. P and q are constants. So if you take a look at that first one, number 1, we would know that the x-intercepts, okay, you would find the x-intercepts when you let y equal 0. So we know that x plus 5 equals 0, or x minus 1 equals 0, so we get 1, or 1 and -5. So those must be our x-intercepts. So now we know that our quadratic is symmetric, so we could go ahead and find the axis of symmetry. Go ahead and pause the video and find the axis of symmetry. Okay, so we know that if our x-intercepts are at -5 and 1, the midpoint of -5 and 1 is -2, so we know that the axis of symmetry is at x equals -2. All right, we still need to find the vertex. So what we're going to do is we're going to let x equal -2, and we're going to substitute -2 into the equation for x to find y. So you would end up with y equals +9. So we know our vertex is at -2, 9. Our axis of symmetry is at x equals -2. We know that we're going to have a maximum because, again, we have a -1 for our a. So our vertical stretch would be 1, and we'll have a reflection over the x-axis if you're thinking of transformations from your parent function. So we might want to do that. So again, for our parent function y equals x squared, we go right 1, up 1. So here we're going to go right 1, down 1. We're going to go to right 2, down 4. Left 1, down 1, left 2, down 4. Notice you would also on your parent go right 3, down 9, right 3 up 9. So we're going to go right 3, down 9, and right 3, left 9. Left 3, down 9, and right 3, down 9. So again, consistent with our x-intercepts. So again, our domain is all real numbers, and our range, our maximum y value is 9. You go ahead and try the next one. Pause the video and try the next one. Find the vertex, the axis of symmetry, get some points. Go ahead and sketch a graph. Go ahead and pause the video now and give it a try. So from factored form, if you let y equal 0, you could find the x-intercepts fairly easily. You could say x equals -3 and x equals 1. So again, we want the midpoint to find the axis of symmetry. So we know that the axis of symmetry must be at x equals -1, which is halfway between -3 and 1. Now we need to find our vertex. Go ahead and let x equal -1 and find the y-coordinate of the vertex. We know that our x-coordinate of our vertex is -1, so the y-coordinate is -8. So we end up with a vertex at -1, -8. So again, we're going to have a minimum because our a was 2. Notice we could compare this to the graph of our parent function y equals x squared, where you typically in our parent function we go right 1, up 1, but again over here we have a vertical stretch by a factor of 2, so we go right 1, up 2. We could go left 1 up 2. We could go right, instead of going 2 comma 4, like again right 2 up 4 like our parent function, our vertical stretch is 2, so we go right 2 up 8, which is consistent with our x-intercepts, left 2 up 8. But if we want to define the domain, we know that the domain is all real numbers, and the range, we would need our smallest y value, which was -8. So the range is from -8 to infinity. Great job, everybody. We just graphed quadratics from 3 different forms.